Heyo, welcome to Shortcut. In this video, I'll show you how to build a Tug of War project with LEDs. So there are push buttons on the left and the right side, one for each player. The player who pushes the fastest will pull the light to his or her side and win the game. After someone wins, the light will reset and light up at the start position. So which components do you need for this project? 11 red LEDs, but you could also use other colors. 11 resistors with a value of 200 ohm. You can take a higher or lower value, but try not to go lower than 160 ohm. 2 push buttons, a breadboard, an Arduino Uno, and jumper wires, but in the game we have to draw wires so you won't see it here. Let's start building the project. First, I'm going to spawn a breadboard and place it here. Then we'll need 11 LEDs. So I'm going to place the first LED with the cathode pin in B26 and anode pin next to it in B25. Now we can place the other 10 LEDs next to this one in the same way, so short pin left and long pin right. The next step is to place the resistors vertically in the same column as each negative pin of an LED, so the top pin of the resistors start in row E. Here I'm going to set the value to 200 ohm. Now we'll add the 2 push buttons. The first one will be placed vertically on the left side, with the left pins in column 30. The right one has the right pins in the first column. The next step is spawning the Arduino Uno, or in this case Shortcut Uno, and place it above the breadboard with the digital pins on top. From here on, we need to place the wires. Start with digital pin 12 and connect it to the anode of the most left LED. Then do the same with the other digital pins and stop once you have connected pin 2. The next step is to connect all the components to the ground or GND pin of the Arduino. Connect the GND pin to the most left hole of the negative row at the bottom. Draw wires from the negative row to the push buttons and resistors. The last step is to connect the push buttons with the analog side. Connect A0 with the top left pin of the left push button. Then connect A1 with the top left pin of the right push button. And lastly, I'm going to add a 9-volt battery as a power source. Connect the plus side to the V-in pin and the negative side to the GND pin. Now that all the components and wires are connected, we can go through the code. You can also find the code on our website shortcut.com. The link of the blog post is in the description. Let's go through the global variables first. Here we have two integers and both values are 5, because the most center LED is a 6th LED, but we have to start counting from 0, so that's why it's 5. Then we have two integers to keep the previous state of the buttons, and two unsigned longs to keep the start time of the last press on the buttons. We start at digital pin 2, and there are in total 11 LEDs. The left button input is A0 and the right button is A1. This last one is a wait time before another press will be checked again. In the setup function, we set a pin mode of both push buttons to input pull-up. Then we set all the LED pin modes to output and use digital write to set it to low and turn off the lights. We start with the middle LED set to high, so it lights up. In the loop function, we keep the time at the start of this function. This will be used later on. In this part, we handle the button inputs. First, we read the current states of both buttons with digital read. Then we check the button states. If the current state of the left button is low and previous is high, and if the time between button pressed and now is higher than the wait time, then we update the press time and current LED position. The same is happening here for the right button, but instead of increasing the LED position, we decrease it here. After that, we update the previous states of both buttons. In the next part, we update the previous and current LED positions. So if the current LED position is not the same as the previous one, then we turn off the previous LED position and turn on the current LED position. And here we set the previous position back to the current position. At the end, we check if the current LED position is lower than 0, then the right player wins. And the win function gets called, where there is a delay of 2 seconds and the position will be reset to the middle LED or 5. Here the same happens, but for the left side. So if the current LED position is higher or equal to the LED count or 11. And after this, the loop function starts again. Now I'm going to play mode and see if the code will work. So if I press on the right button, it will keep moving to the right the more I press, and after 2 seconds the middle LED turns on. Because I can't press the two buttons at the same time with my mouse cursor, I can bind a key to each button. Let's say I want to use key 3 for the right button and key 1 for the left button. This way I can press the two buttons at the same time as well. Here we have the project with real components. The wire colors are a bit different, but it works the same way as the one in Shortcut. That's it for this video. Press the like button if you enjoyed this video and subscribe to the Shortcut channel for more. Don't forget to click on the bell icon. If you have any questions, feedback or project suggestions, leave a comment down below. Thanks for watching and see you next time.